Ferrari has been working intensively in the days following the 2025 Belgian Grand Prix to further refine and enhance the mechanical setup of its new rear suspension, which made its debut at the Spa-Francorchamps circuit last weekend. For the Hungarian Grand Prix, the Maranello-based team has decided to fit the SF25 car with the same high-downforce rear wing configuration that was previously used on the narrow streets of Monte Carlo, in a strategic move to maximize aerodynamic grip. However, one key area of attention will be power unit consumption, which could be a concern under these conditions. The Hungaroring is a circuit that presents an entirely different technical and driving challenge compared to Spa. The Hungarian track, which traditionally hosts the final race before the Formula One summer break, is characterized by a twisty layout with mostly medium speed and slow speed corners, and only a single main straight. As a result, teams typically configure their cars to run with the highest possible aerodynamic load to maximize downforce and grip through the technical sections. Ferrari has opted to bring back its Monaco-Spec rear wing to Budapest. This version features a long-chord main plane that is almost flat across its span, combined with a high-angle flap topped by a prominent nolder. This element is especially useful in generating additional vertical load in the slower parts of the track. A slight curvature is present only near the end plates, optimizing airflow at the outer edges. On the front end of the SF25, the front wing has also undergone a series of technical revisions. Notably, the final flap element is now significantly stiffer and more rigid, particularly in the area that stretches from the central portion of the wing all the way to the outer end plates. This modification has been specifically introduced in an effort to address and mitigate the SF25's persistent and well-documented understeer issues, improving the car's initial turn-in response during corner entry, and enabling the drivers to make better use of the increased overall performance potential that has been unlocked by the new rear suspension system. This modification has been introduced to help combat the SF25's chronic understeer, enhancing the car's initial turn-in response and allowing the drivers to make better use of the increased performance potential unlocked by the new rear suspension system. Ferrari's team principal Frédéric Vasseur, who has recently signed a new multi-year contract extension with the Italian racing team, expressed a strong sense of confidence and optimism ahead of the upcoming Hungarian Grand Prix. The experienced French manager emphasized that the substantial efforts made by the engineering staff and technical personnel at the Scuderia's Maranello headquarters have resulted in the introduction of a significantly upgraded technical package aimed at further boosting overall competitiveness and performance. Frédéric Vasseur stated that Ferrari's primary objective for the Hungarian Grand Prix is to continue the team's current upward trajectory. At the Belgian Grand Prix, Charles Leclerc secured Ferrari's fifth podium finish of the 2025 Formula One season, and the team now sets its sights on challenging McLaren for stronger race results and better championship standings going forward. Whether this renewed sense of ambition and technical evolution will ultimately translate into tangible performance gains on the track remains to be seen, and the free practice sessions scheduled for today will provide a much clearer and more accurate picture of the car's real potential. However, what is already certain and confirmed is that the Italian team has carried out an in-depth technical analysis and performance review immediately following the Belgian Grand Prix at Spa. While the racing team was traveling and making logistical preparations for the Hungarian round, the Ferrari engineers and technicians have remained focused on carefully evaluating the SF25's braking behavior and performance. The recent introduction of a revised rear suspension geometry featuring increased anti-squat characteristics has contributed to making the car more stable under braking and more predictable for the drivers, particularly during the deceleration phase. The valuable data gathered from this analysis was then utilized to fine-tune and further calibrate the rear-end setup, with the aim of extracting the maximum possible performance from the updated aerodynamic configuration. Particular and focused attention has also been directed toward the braking system as a whole. Brake cooling represents a crucial area of concern at the Hungaroring circuit due to its specific track layout and localized microclimate. The circuit is located in a natural basin which tends to trap heat and humidity, creating an environment where high ambient temperatures combined with elevated humidity levels can pose serious challenges for the proper functioning of the braking components. To effectively address this issue, Formula One teams typically employ larger brake ducts, allowing for increased airflow to reach both the carbon discs and brake calipers, thereby maintaining optimal operating temperatures throughout the entirety of the race distance. A recent and illustrative example underlining the critical importance of fuel and energy management occurred during the Belgian Grand Prix, when seven-time Formula One world champion Lewis Hamilton was forced to adopt lift-and-coast techniques during the final laps of the race in order to conserve fuel and avoid running out of energy before reaching the checkered flag. While the Hungaroring is generally not regarded as particularly demanding on the power unit when compared to other circuits on the calendar, many teams often opt to use slightly older internal combustion engines from their available pool. It still requires a degree of caution and special attention when it comes to fuel consumption. This is primarily due to the fact that high-downforce aerodynamic setups inevitably result in increased drag, and the average lap speed at the Hungarian track is approximately 30 km per hour higher than that of Monaco. Although the circuit may visually appear to be slow and twisty, it is not as slow as it might seem at first glance, especially when analyzed from the perspective of engine efficiency and fuel management strategies. With only one short straight, the key to success lies in achieving high cornering speeds through many low and medium speed turns. Equally important is carefully managing airflow to ensure optimal cooling for both the engine and brakes. The Hungaroring circuit is well known for its tight and twisty layout, featuring very few high-speed sections. The high asphalt temperatures combined with short straights make cooling management a critical challenge in Budapest. Ferrari will therefore balance the need for adequate cooling with the goal of minimizing aerodynamic drag in these demanding conditions. It's all about finding the right compromise between cooling requirements and aerodynamic efficiency, essentially balancing reliability with performance. The SF25 has been designed with several cooling configurations intended to cover a wide range of needs, while keeping the engine and brakes within safe temperature limits at the lowest aerodynamic cost possible. This cost primarily comes from increased drag caused by more aggressive cooling setups. Each cooling level is achieved using a series of specific and modular components, both at the air intake side, such as side pod inlets and brake cooling ducts, and at the exhaust side, including louveres, engine cover openings, and chimneys. Each of these elements can be partially opened or closed depending on the operating conditions. Finally, at the Hungaroring, the aerodynamic penalty caused by increased drag is less severe compared to other circuits, precisely because of the absence of long straights where top speed matters most. In summary, Ferrari is approaching the Hungarian Grand Prix weekend with a highly focused, methodical, and technically detailed strategy, aiming to fully exploit the benefits of its latest aerodynamic and mechanical upgrades. The team's objective is to continue closing the performance gap to its main rivals, namely McLaren, and to maintain the positive momentum built up in recent races, heading confidently into the Formula One mid-season summer break.